In school, the way of conveying ideas is through words. A teacher walks up to the board, writes words, says words. Students receive books with words and are expected to respond to questions with words. The vast majority of teaching is done through words. But let's look at who we're trying to teach. Focusing on California, 25% of students are English language learners. Another 15% have language-based learning difficulties, such as dyslexia. An additional 20% fail language comprehension tests. And a large portion of the remaining students characterize themselves as visual learners. Left over, there's only a tiny little segment of students for whom current teaching methods are a good fit. And I was one of those students way down there. I have dyslexia. And for me, words were really big learning barriers. I mean, I didn't even learn to read until I was in 5th grade. Years later, I read a biography of Albert Einstein, and I discovered that he was dyslexic too. And one quote from him really struck me. He said, "The words or the language as they are written or spoken don't play any role in my mechanism of thought." Wow. So if words are not needed for great math and science thinking, then maybe words aren't needed for great math and science teaching. And so when I started investigating how we might be able to teach without words, I was shocked at how language-heavy even preschool materials are. I mean, look at this worksheet I ran across. Color the shape that is the same as the first shape in each row. They even have it in Spanish. So I wondered, what would happen if we remove all those words and hand this over to some 4-year-olds along with some crayons and don't say anything? This is what happens. We didn't tell them what to do, and so they did whatever they wanted. But how do we tell students what to do without words? Here's one way. Interactive software with informative feedback. If you click on the wrong thing, it shows you why you were wrong. And when you click on the right thing, it shows you why you were right. And you can help a little penguin across the screen. Okay, so this works for shapes, but what about things like word problems? I mean, how can we do those without words? Well, here's a typical word problem from a 2nd grade textbook. Ostriches have 2 legs. How many legs does a group of 3 ostriches have altogether? We can translate this into a completely word-free problem. Again, if you don't know what to do and you get it wrong, say you pick 8 legs, it shows you why that's wrong. We picked too many. And when you get it right, it shows you why it's right. The feedback teaches the students. It doesn't just replace the words. It provides more instruction than the words ever did. And this visual feedback is so powerful that we can use it to teach really sophisticated subjects. This is pretty sophisticated. This is a page from an Algebra 1 textbook. A very language-heavy approach. And here's what it does to our kids. Over 70% of students fail to learn this stuff. Now here's a visual game teaching that very same content. Here students are learning to factor and solve quadratic equations, all done visually with informative feedback. And because these games allow students to touch, feel, see, and interact with a math, it's able to clear up many of the mysteries about how and why math works. For instance, when only done through words, students often find it mysterious why multiplying 2 negative numbers produces a positive number. But when done visually, like in this block stretching game, students can see how multiplying by a negative number not only stretches, but also flips the block in the opposite direction. And then when you multiply by a negative number again, it ends up flipping it again back to positive. It's not mysterious anymore. It's fascinating. And so we've created hundreds of these games to teach all the math concepts from pre-K through Algebra 1. Here are some exponents and some fractions. We're basically able to boil all math down to how do you help a little penguin across the screen? But does it work? UC Irvine recently conducted a study where they put these visual games into 106 schools in Orange County. And after 1 year, we're able to triple the rate of growth in math proficiency. And last year, we replicated this result in Silicon Valley, Las Vegas, Chicago, and Houston. This simple innovation of removing the language barriers is able to elevate math proficiency everywhere we put it. And of course, increasing standardized test scores is great, but we will also want to make sure we increase real mathematical thinking. And we definitely see that too. Because instead of just throwing a bunch of words at students, we create rich opportunities for them to connect their own dots in their own heads about how math works. And when students play an active role in figuring things out, they want to talk about it. It sparks mathematical talk. And in this way, a language-free approach can actually improve language skills.
Every student is different.
Score! 6 por 7 son... I'm done!
So how can we reach them all at their own level? With ST Math, learning is personalized. Each student takes their own path and works at their own pace. When they demonstrate that they've mastered a concept, the student moves on to the next level. Over the course of the school year, a student will solve over 5,000 interactive puzzles, and each one provides animated feedback that adapts exactly to the student's response. This informative feedback creates an environment where students learn by doing and discover that every mistake is an opportunity for growth. As they play, students encounter increasingly rigorous problems, which challenge them to think creatively and apply their knowledge in new ways. Throughout the process, students connect and innovate. Unlike any other program, ST Math allows students to see the math, animating in real time, responding to their actions. Once the student has a conceptual understanding of the math, more traditional symbolic representations are introduced, the type that they'll see in textbooks and on standardized tests. With their deep conceptual understanding and the well-developed patience to persist through new challenges, students' mathematical knowledge shines. And over time, we see that by providing a math program that allows every student to be different, the students, as a group, actually do better. At schools across the country, students are improving in math when they use ST Math, because ST Math makes math visual, engaging, personalized, and creative, so that students can see the math and grow.